So it is a new kind of mathematical quantity you can think. Just a moment. So in order to call something as a vector, so there are many things we see where telling how much to do is not enough. Even we have to mention in what direction I must do that thing. Like if I ask you how to reach a place A from place B, and suppose the distance between these two places is 10 kilometers, you can't just say like you travel 10 kilometers. I have to specify in what manner I must do that 10 kilometers. Correct, no? Next moment. Keep on giving feedback in between because otherwise it feels like whether whatever I'm telling is going through or not.
Recording in progress.
Just a moment. For something to be called as vector, necessary condition is it should have direction, and there's something called magnitude. Magnitude means how much to be done. Suppose to reach a point B from some point A, I have to travel 10 kilometers, and point B is in eastward direction. So I have to travel 10 kilometers towards east. So I have to mention how much to do? 10 kilometers. That is going to be called as magnitude. And in what manner or in what direction I must do that thing? Eastward. That is going to be the direction. So for anything to be called as vector, it must have magnitude and direction. That is necessary condition. Okay. So for example, if I tell you check out this quantity which is temperature. So this temperature thing has got no sense of direction as such. So straight away it is not a vector. So something not having direction, guaranteed it will not be a vector. But that does not mean that something having direction is always going to be a vector. So for example, there is something called in math, or there's a word called sufficient condition. So something having direction and magnitude can be a vector, not guaranteed that it will be a vector. So if something having what is the sufficient condition to be something to become a vector is, it should follow vector algebra. Correct. And what is vector algebra? That is what we are going to see in this chapter. I will tell two examples first. One example I can give of something which is electric current. And even though, electric current will be having some direction. So even though it has direction, it is not a vector. Okay, you can hear me properly, you're not listening any background noise, no? Even though it has direction, it is not a vector. The reason is it do not follow triangle law of vector addition. There's a madam sitting next to my cabin teaching so loudly and disturbing me. Some people don't have civic sense, man. Okay, got the point, no? Even though it has direction, it is not a vector. The reason is it do not follow triangle law of vector addition. This thing clear, no? So what is triangle law of vector addition that we are going to see? So I drew triangle instead of writing triangle. I hope you got that thing. One more example is, but maybe I will tell it some other time, or maybe I'll tell you. Angular displacement when finite is not a vector. When it is finite, finite, I hope you may not be understanding it now. Finite means something which is measurable, something that you can see with naked eye. And there's one more term that will come very often that is called as infinitesimally small. Infinitesimally small will be it's like antonym of infinitely big. Something which is infinitely big, you understand what it might mean. So what can be opposite of that? Something very, 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 very small that will be called as infinitesimally small. Something is not that kind of small, like virus or like atom kind of small. Such thing will be called as finite. So angular displacement is not a vector. Not it is not always true. It is true when it is finite. Okay, what a statement I am giving is for the case when angular displacement is finite. So when angular displacement is finite, it is not a vector. There is, even though it has direction, obviously it has direction. The reason is it do not follows. There's something called as commutative nature of vector addition. That too we are going to see in this chapter. So right now, you can maybe you may not be understanding what is triangle of vector addition and what is the meaning of commutative nature of vector addition. So that is something we are going to see very soon. Okay. Next thing is like how to represent a vector graphically. So the symbol we use for representing a vector is, suppose if A is a vector quantity, then to tell that okay this is a vector, we put a arrow over the head. And suppose that a vector is regarding traveling 10 kilometers in the eastward direction. So what we are going to do, we are going to draw an arrow. Got the point? Now suppose vector A is regarding traveling 10 kilometers towards eastward direction. Then what you will do, you will be drawing an arrow which will be pointing towards east. And you will draw an arrow which is pointing towards its towards east, correct? But what will be the length of that arrow? So what is the length of the arrow will be, tell me, any idea? 10 kilometers. But who will draw 10 kilometers big arrow, man? So we will be taking some scale like the way we draw a map, no? Like 10 kilometers on ground is like 1 centimeter on paper. So the length of the arrow is going to represent the magnitude, no? It's not literally going to be same as 10 kilometers. Whatever length I draw, in our head we will understand it is 10 kilometers. So to represent the magnitude of this vector A, so what is the magnitude it has? 10 kilometers, no? So to represent magnitude of a vector, we use this symbol. Suppose I have to write the magnitude of the vector A. So we write that vector A with his arrow symbol, and then we put this bars which is called as modulus. Okay. So the magnitude of this vector is how much? 10 kilometers. So modulus of vector A is 10 kilometers. Got the point, no? Also called as modulus of vector A. So the length of the arrow is going to represent the magnitude. I hope this thing is clear. Now, when I can say two vectors are equal, any idea? So whenever the word vector comes, it comes attached with two information. Or you can think like vector is some mathematical quantity. And whenever it comes into, when we talk about him, it comes attached with two data. One is the data, which is in what is the direction. Other data is what is the magnitude. So whenever someone tells vector, you will hear magnitude, direction, magnitude, direction. Two things always you will be hearing. So equal vector means equal direction and equal magnitude. I hope this point is clear. I can take a new page. Sakti will clear, no? Sakti will clear, no? And
Yes, sir.
okay then. Okay, your Motorola. Okay, you've joined from phone, man. Then maybe cast that phone in TV if possible. In case if you're joining from phone. In case if you don't have option, maybe you manage somehow. But next time you try joining from some big device, maybe cast it to TV, maybe. Okay. I don't know. Small device, I don't know whether people can understand properly or not. Okay, now, suppose here I have drawn an arrow representing vector A, and it is of some length. And maybe that arrow is pointing towards east. And I've drawn an arrow of some length to represent the vector A. Now, I'm going to draw another arrow. You see, this red arrow is of same length as the length of the blue arrow. It's not looking like that, but you think they are of equal length. And this red arrow is, and, and this red arrow is in same direction as this blue arrow, you see. Now I'm going to shift this arrow parallel to itself. Maybe I'll draw him here. So is it correct to use this red arrow to represent the vector A or not? Think and tell me. Suppose vector A is of length 10 kilometers. So we can take some scale. Like 1 kilometer is equal to 1 centimeter. And using that scale, we will draw an arrow of length 10 centimeters. But he is of length 10 centimeter. But what really runs in our head? 10 kilometers. No, because after that scale selected, 1 centimeter is 10 kilometer. 1 centimeter is 1 kilometer, correct? So if you read map also, it will be written like that. 1 centimeter on paper is this many kilometers on ground. So now I have drawn another arrow, maybe somewhere else, of same length and pointed in the same direction. So tell me, I can use this red arrow to represent A or not. Tell me fast first, don't take that much time to reply, man. You can type also, or maybe you don't want to type, maybe you will type. You can do this thing also. But here, yes means thumbs up, or maybe no means I don't know what to do. Yeah, okay then. So what I'm trying to tell here is, even I can use this one to represent the vector A. Where I have drawn that arrow doesn't matter. What is the length of the arrow matters same. Direction of the arrow matters same. So two things same, you don't think of third thing because only these two things are supposed to be same for telling two vectors to be equal or not equal. Correct? Mm, No, next thing is I'll write a statement. A car going in Chennai with 10 meters per second towards east, and another car in maybe like China going with 10 meters per second towards east. Maybe a blue car in Chennai is going with 10 meters per second towards east, and another red car in China going with 10 meters per second towards east. So tell me, the velocity of these two cars same or different? You will say, sir, how same? They are different car. But I'm not talking about the car, you get it, no? I'm talking about the velocity of the car, no? Correct. So two, maybe one Chinese guy also having black hair, Indian guy also having black hair. So I can say like, see, the hair of these two guys are same. You can't say like, man, different guys hair, how same? So obviously, you get the point. So the velocity of this two car is same or not? So velocity vector of both the car same. So what I'm trying to tell is, see, upon shifting, so where I draw the vector, you don't get confused by that. If direction same, length same, vector same. So on shifting a vector parallel to itself, the vector remains unchanged. On shifting a vector parallel to itself, the vector, seriously man, I'm recording this thing or not? Yes, recording. Thought I forgot to put it on record. On shifting a vector parallel to itself, the vector remains unchanged. Or even I can say on transporting a vector parallel to itself, the vector remains unchanged. I hope this thing is clear to everyone. I can take a new page. Shaktivel, I can take a new page, no man. Shaktivel, I can take a new page. Okay then. Next thing is how to find angle between two vectors. See, simple things, but man, boring thing, man. Teaching math kind of things is like so boring. feeling sleepy in telling these things, but I'm trying to somehow keep myself awake. Okay, but you should be should not be feeling it like that. Now, so the thing is to find the angle between two vectors. If suppose if I tell you find angle between A and B, here in this case the order is important. Like I'll tell you what it means. Angle bit. Suppose if I ask you and find angle between. If you get the shortcut way to right now. This is angle B slash W is between. Find angle between the vector A and B. That is one kind of statement. Another statement is find angle between vector B and A. You get the point order here. Find angle between B and A. Just when I go to staff room, like much disturbance here. Just give me 1 second. 1 2 minutes, okay. बायोलॉजी में मैडम इतना चिल्ला चिल्ला के पढ़ा रही है ना, मूड खराब आता है। कोई क्यों नहीं पढ़ा रहा था, दिमाग खराब। वरना वो क्लास ले रही मैडम, बैकअप सोच सोच के पढ़ाना होता है, रट के थोड़ा ना उल्टी करना होता है हम लोग को। Okay, so see how to figure out. Order is important means if I ask you find angle between vector A and B, or if I ask you find angle between B and A, both are not like same thing. Your order is important. So what we say in such case, it is non-commutative in nature. In order to get the angle between two vectors, vectors should be given to us. Right. Just a second. Vectors should be given to us in this arrangement in which their tails are together, also called as co-initial arrangement. Or they should be given to us in this arrangement, which is called as coterminous arrangement, or heads together. You get the meaning of why coterminous. Terminating points are together. Why co-initial, the starting point, are together. If they are not in any of these two arrangement, not a problem. You shift one of the vector parallel to itself to bring them in either this or that arrangement. If not in co-initial or coterminous arrangement, shift one of the vector parallel to itself and y, obviously, to bring them in initial or coterminous arrangement. Now, if vectors are already given to us in any of this two arrangement. Then what to do? Suppose this is our vector A and this is our vector B. Then you check what is being asked whether they're asking you find angle between A and B or angle between B and A. So check who is coming first in the asking order. So maybe if I ask you find angle between A and B, so then you check out in order to suppose maybe you can think like this also. Think of turning the arrow of A around its tail so as to bring it at the location of B. So in order to do that, you have two choices. You can go through this angle or go around this arrow, the red one, or you can go around this blue one. No? So suppose this blue one is 300 and this red one is 60. So among these two, which is smaller one, 61, so that will be reported as the answer. But just telling 60 will not be enough because if I tell you turn 60, then which side 60 you have to turn, man? In the way I have drawn this red arrow, or in the way I have drawn this green arrow, or other way to tell that thing is whether it is anti-clockwise way in and whether it is clockwise way. I hope you know what is anti-clockwise and clockwise. No, anti-clockwise. If you don't know, you ask me, or else I will assume you know. So telling how much the angle is not enough. I have to specify the sense of the angle also. So maybe I hope all of you got the point. Know how to find angle between A and B. Same way if I ask you find the angle between B and A. So same exact thing you do. Since in the asking order B is appearing first, so you start from B and go towards A. And always you will have two choice. One bigger one, one smaller one. The smaller one is going to be the angle between them. So if I start from B and I go towards A, the smaller one, the smaller one is going to be this one, and that is also 60 degrees. But tell me, this black arrow is in what sense? It is in clockwise sense, no? So what we do is the sign convention we use. By sign convention, maybe sometime we don't want to use language like who will write anti-clockwise and headed. I will use something, a symbol for it. So ACW, by that I mean anti-clockwise. And for anti-clockwise, we use plus. For clockwise, we use minus. Okay. So this thing is clear, no? So if I ask you that what is the angle between A and B in this given figure is, so answer will be plus 60 degrees. But we don't use 60, we use radian system, which is pi by 3. So pi by 3 or plus pi by 3. The same figure, if I ask you, find angle between B and A, you get the meaning, no? What it will be minus 60 because that is clockwise or minus pi by 3. I hope you got the point. And I hope you must have understood the logic behind the way we report the angle. You can think like this also. Suppose you're looking at your friend who is like in enemy zone. Maybe your friend is like some fighter or some army man and he's in the field. And you are the guy who is like driving or like piloting a drone. And suppose enemy here and your friend is here and maybe your friend is a sniper rifle guy. So your friend is looking towards eastward direction and then you want to tell your friend to turn towards the enemy and fire at him. So tell me You will tell him to turn through 60 degrees, or you will tell him to turn through 300 degrees if he is really your friend. Got the point, no? You will be telling him to turn through 60 degrees only, the smaller one, no? So to find the angle between vector A and B, what we do? We start from A and we go towards B. I have two choices. Either I can go through this red arrow path or I can go through this blue arrow path. Among these two, which is the smaller one? So smaller one we take because who wants to do extra work, and we want to save time and resource both. So we'll take the smaller one. The smaller one will be reported as the angle between A and B. You want me to write a statement for it? To find the angle between A and B, A is appearing first in the asking order. So start from A, go towards B. Smaller angle, that is the angle between A and B. I hope this statement makes sense to you. You have understood also. I can take a new page. So there's something you have noticed that if angle between A and B is 60 or 60 degree anti-clockwise, then angle between B and A is minus 60 or 60 degree clockwise. Correct. So I will write that thing as a result you should know. If angle between A and B, vector A and B, is theta, then the angle between vector B and A is going to be minus theta. Understood? No? Okay, I can take a new page. If you got it, no? I did it.
Yes, sir.
I have to make it's not there. It's empty. You cannot do anything. Okay, I can take a new page. So I will draw something. You tell me which is what is the angle between the vector A and B. This is our vector A and this is our vector B, and it is told this is 120 degrees. So can you determine the angle between A and B? So mind it, A and B I'm telling, not B and A. A and B and BA, and they are like opposite. One is going from Delhi to Chennai. Suppose many times it has happened to me that I was supposed to book Chennai to Delhi flight. I have booked Delhi to Chennai flight opposite. So it's like that. Angle A, if I ask to find angle between A and B, if I ask you angle between B and A, both are different things. Mhm. So tell me what is the angle will be, any idea? Any idea, man? But I don't have coffee, so I have to drink green tea. But it will take time to make, no? And that much is no time. No? So see, in this case, the vectors are not in the way I want them to be in. So I want them to be in either in co-initial arrangement or co-terminus arrangement. Since they are not in such arrangements, so we shift one of the vectors parallel to itself, not literally in our head. So suppose if I shift the arrow of A and bringing in here, just drawing another arrow of same length as the arrow of A and in the same direction as the arrow of A, just placing the tail of this arrow at the tail of the vector B. So whether I use the red arrow to represent A or whether I use the blue arrow to represent A, both are correct representation. Both correct, but red arrow more beneficial, no? If both correct, both are legal thing, and red arrow is giving me an extra benefit, so we will use red arrow. Correct. Now, if I check out the red arrow of A and the blue arrow of B, they are in the co-initial arrangement. Thank you. They are in co-initial arrangement. Is it not? So now we do the same algorithm. We start from A, we go towards B through the smaller angle between them. So this black arrow is going to be the angle between A and B. So see this red arrow and of A. So this red arrow of A, okay, this one, and this blue arrow of A, both are sitting on the same line. So if that angle is 120, this one, this black one will be how much? 60. But telling just 60 not enough, man. We have to mention what is the sense of the angle is. So 60-degree anti-clockwise. So maybe who will write anti-clockwise? So much headache to write. So angle between A and B is going to be plus 60 degrees or just 60 degrees. I hope you got the point now. What to do when vectors are not in the arrangement I want them to be in. Now, maybe suppose you don't like co-initial arrangement, maybe you want co-terminus arrangement. So that too can be done. So I will shift the arrow of P. So even I can shift B parallel to itself to bring the vector A and B in co-initial or co-terminus arrangement. So see what I have done here is I am shifting the arrow of B parallel to itself here, placing the head of the arrow of B at the place of the head of the arrow of A. So this black arrow of B can be also used to represent B because it is in the same direction and it is of same length. Now if you check out the blue arrow of A and the black arrow of B, what kind of arrangement it's going to be in? Co-terminus arrangement. So we start from A and we go towards B through the smaller part, and what is that is going to be? So that is going to be 60 degrees because they are like something called as vertically opposite angle or some opposite angle. No, there is 60 degrees. Just 60 not enough. I have to mention what is the sense. So tell me what is the sense of this arrow or this angle is. I hope all of you can see that this is also anti-clockwise. So whatever way I use, answer is going to come same only. Whether I bring them in the co-terminus arrangement like this one or co-initial arrangement like previous one, answer will be same. I hope finding angle between vector A and B clear. Clear, no one? I'll take a new page now. Next thing is finding sum of two or more vectors, also called as addition of vectors, or also called as finding resultant of vectors. So when we add few vectors, suppose if I add vector A, B and C, maybe three vectors I'm going to add. And right hand side, I have to write something. So A, B, and C are vectors, vectors, vectors. And I add them. What I must expect, not like a snake or tiger out of it. No, man. Adding vectors will give us something which must be a vector only. That is like obvious. So one thing is I can say that adding them we must be seeing some vector only. Correct. So what really is the meaning of that vector we get by adding few vectors? So two things are there. How to add vectors, one thing. Another thing is why to add vectors. Both we must know. So first thing is you should know, like which is more. Suppose a person is to be taught how to use gun, so he must be taught also why to use gun. No, otherwise he might use that gun to kill doggies on the road. Also, who knows, man? Correct. So adding two or more vectors. First of all, what it means. I'll write down that statement, then I will explain that also. Adding two or more vector means finding a single vector, and that single vector is also has got a name. Like you will be given some bunch of resistors and you will be told to find R equivalent. What really is the meaning of finding R equivalent was? Like I give you R1, R2 in parallel, then I ask you find R equivalent. What was the purpose? Purpose was to find one single resistor, the one which is going to do the same exact job as the ones that you are adding up, or the ones that you are finding, the ones whose you are finding the equivalent, no? Correct? So instead of using the R1, R2 like that, I can use one vector which is R equivalent, the one which is going to bring same outcome in the circuit. So same way here. So every vector has some purpose. So suppose if A, B, and C are three force vectors. So what happens when we add them and why we add them? That is, I'm telling first. Adding two or more vectors means finding a single vector, the one which brings same effect as the ones which are added when they act together. So what it means, if A, B, C, all three are acting, then instead of this three, I want to use one single guy, the one which is going to give me same outcome. So whichever that vector, that one single vector will be, that will be called as resultant of A, B, and C. It means it's like A guys, if person A can repair two bikes in a day, person B can repair three bikes in a day, person C can repair five bikes in a day. So together they can repair 10 bikes in a day. Then he found one nice guy R who can repair 10 bikes in a day. So what you will do? You will fire ABC and you will hire R, no? So I hope you're getting the point, maybe. So adding two or more vectors means finding a single vector, the one which brings same outcome or same effect as the ones which are added. When the ones which we are adding, they all act together. Okay. So maybe I'll give some example which is like more physics one. So I have a block on which two forces are acting. One force whose name is A and it is of magnitude 20 units, and right side. Another force is vector B, which is of like 5 units and acting in the left side. So tell me, instead of this A and this B, what one single vector I must use? The one which is going to bring same effect on the object. Can you tell me? So for that, you don't have to know physics. Common sense is enough. That will be your 15 units, no? I hope you got the point. Like, what is the purpose of adding few vectors? Okay, I can take a new page.
Yes, sir.
One more example I'll give. And in this example, we are going to use something which is called as triangle law vector addition to add two vectors. And right now we don't know what is triangle law totally. Still, you will be using triangle law without knowing that you have used triangle law. Suppose this is eastward direction, and maybe before I tell you that, I have to tell one thing, which is like in physics we use an angle which is whose approximate values I'm writing. Okay, you take a right angle triangle having sides 3, 4, and 5. So in that triangle, this angle will be approximately 53 degrees, not exactly, and this angle will be 37. So you have to use this triangle in case if I ask you find sine 53, that's going to be 4 by 5. Cos 53, 3 by 5. Like that others you can find. Sine 37, 3 by 5. Like others you can find. So again, these are approx values. Don't use these values in math. Just in physics you will be using it. Okay, then coming back to the main point. So this is our east and this is northern direction. So a person starts moving from origin, okay, and the point from where he starts moving, maybe that place only, maybe I'm calling it as origin, and he's moving on ground. So obviously, only things are going to happen is going to be in 2D plane. So what he does is first he does 3 kilometers along east, and doing 3 kilometers along east is called as vector A. And for vector A, I'm going to use the symbol PQ. Where चल जाओ disturb नहीं हो रहा Next, what he does, he travels along north by 4 kilometers, and that is I'm going to be calling it as vector B. And to represent vector B, we are going to use the arrow segment QR. So tell me, on doing A and B back to back, what is the effect is that person has reached the point R from P, correct? So what single thing I can do instead of this, what is this color, man? Violet color, no? Yeah. Instead of doing this violet arrow and that black arrow, what single thing I must do so as to have same outcome is to do PR or not? There is something you don't need to know physics for understanding this. Instead of doing A and B, what is doing A and B? Traveling 3 along east and 4 along north. what I can do, I can do PR, correct? So here what I will say, adding PQ and QR, what is the thing which can replace these two? Is the arrow PR, no? Correct. But what is PQ? It is the another name of the A. And what is QR? Another name of the vector B. It means vector A plus B is equal to PR. So what it means really? It means adding A and B, we are going to get a vector which is represented by the arrow PR. Now it is our task. If I want to find the magnitude of that vector, I must find the length of the arrow, whatever is the length of the arrow segment PR. Now I have to know, if I want to know the direction of the vector, I will see what is the direction this arrow is pointing along. So see, this is our eastward direction that we know. And if I can find this angle, whatever this arrow PR is making with eastward direction, I can use that angle to report the direction of this vector. Now, how to find the length? That is some math thing you can do totally. And suppose if you don't know math, maybe we can do this also. I can draw an arrow PQ of length 3 centimeters using a scale 1 centimeter is equal to 1 kilometer. And then I can draw arrow QR using the same scale. And then joining PR, we can measure PR and we will find it to be 5 centimeter. Or if I know Pythagoras, I will use Pythagoras. So once I get, okay, the arrow segment PR is 5 centimeters. And what is 1 centimeter is 1 kilometer. It means PR is of length 5 kilometers. No? I hope you got the point. So here I will say the resultant of A and B is given by the arrow segment PR. So from now on, if I write A plus B, or if you find A plus B written somewhere, sometimes you don't see them as two things. You see them as one thing. What one thing? The one that you get by adding A and B or by doing the operation, whatever is that operation, A plus B. So if I write modulus of A plus B, what really you understand? Means I'm talking about the vector, the one which you get by adding A and B. Means I'm talking about the magnitude of the vector, which is the outcome of A and B, or magnitude of the resultant of A and B. Right? I hope this point is clear. I can take a new page.
Yes, sir.
Now, next thing is the triangle law of vector addition. See, every time, just like that, we can't apply triangle law. Vectors should be given to us in a certain fashion or in a certain manner, then only we can apply triangle law. Suppose if the vectors that we are going to add using triangle law, and we can add two vectors using triangle law to find the resultant. Suppose if I have to add vector A and B, and this is our vector A, for which I'm going to use the arrow segment PQ. So P is the tail of the arrow of the vector A, is it not? And Q is the head of the arrow of the vector A. Then check out this blue arrow of P. And to represent vector B, we are going to use the arrow segment QR. So where is the tail of the arrow of B? That is at Q. And where is the tail of the arrow of head of the arrow of vector B? That is at R, no? So you see what kind of arrangement of our vector A and B are in. Tail, head, no, then tail head, like as if there are two bogies of a train engine, no, both of them facing along same direction, sort of, correct? So this arrangement is called as tailhead arrangement. So we can apply triangle law when vectors are given to us in tailhead arrangement. If not, then we shift one of the vector parallel to itself to bring them in tailhead arrangement. So in order to apply triangle law, must be given to us TH means tailhead arrangement. If not, shift one of the vector parallel to itself to bring them in tailhead arrangement. Okay. Now what really this law's statement is, I'll tell you, suppose I have to add this to vectors A and B, for which I'm using this red arrows. Then triangle law will tell you which arrow segment is going to be representing the resultant of these two vectors. Okay. And we have already used that thing without knowing it. So what you do, you draw an arrow which is starting from the tail of the first vector and terminating at the head of the second vector. This is P, this is Q, this is R. So one way to give the statement is like this. If two vectors are given in TH arrangement, then their resultant is given by the vector or given by the arrow which starts from the tail of first vector and terminates at the head of second one. Or maybe you can do it like this also. You write the vectors A and B, which are represented by P, Q, and QR. So when you write them like this, you recognize which is the tail, which is the head. So PQ tail is at P and PQ head is at Q. Now you see PQ ending at Q. So next guy is starting at Q only, no? Then it will be only going to be in tail head arrangement. Now Q is starting at Q. So tail of the QR is, tail of the QR is Q and head of the QR is R. So you take the tail of first vector and the head of the second vector. So you see Q is like sandwiched between P and R. So what happens? You just eliminate QQ, what remains? PR. So that PR will be the arrow which is going to represent the vector which is the resultant of A and B. So for that I'll be writing A plus B. So here A plus B doesn't, you should not take them as two things. You see them as one. Which one? The one that we get upon adding A and B. So the triangle law will be telling us which arrow segment is going to be the arrow of the resultant vector. Now it is our task to do some simple math things to find the length of the arrow segment PR. Now same thing it was there also, no? PQ and QR are what? What kind of arrangement they are in? Tailhead, tailhead. And the resultant of this two is given by which arrow? PR. And what we did to find the length of PR? We applied Pythagoras. Correct. And what we are going to do to tell the direction? So one way to report direction, what is like common way is I will be reporting the angle made by the PR with the first vector. Why? Because if I tell you add vector A and B, then vector A is given to us. Means in what direction vector A is going to be that we know. So here like vector A is along eastward direction. So if I tell regarding the vector PR that he is making this many angle, phi angle from eastward direction, is it not enough to figure out in what direction vector PR is acting along? So reporting this angle phi is going to enable us to locate in what direction I must draw the arrow PR, correct? So phi angle can be used to report the direction. Okay. So I'll take a new page. So try to do this proof on your own or in the next class, which is with timing I have told for vectors 2:30. I will start from here. I'll write the result now. You try to prove it in the break. Take any book, Google it, or anything. Simple things only, man. Now this is our vector A. This is our vector B. Now to find the angle between them, we do different kind of drama. No, we shift one of the arrow parallel to itself. No, so I am drawing this dotted red arrow to represent vector A only. Then we start from A, we go towards B. This will be the angle between them, which I'm calling it as theta. So the resultant vector is going to be represented by the arrow segment PR. So PR represents A plus B. So prove this thing on your own. That length of PR is same as the length of the resultant of A and B. So that will be modulus of A square. Prove this thing on your own. It's like so boring thing, man. I'm getting like sleepy to teach these things. And this angle phi, you find out tan of that angle. Tan phi will be equal to B sine theta. But essential thing, you can't survive without knowing vectors in physics. That's why even though it's boring, I have to take these things. But it should be interesting for you. Okay. So try to prove it on your own. If not, I will be doing it obviously. So maybe we'll end our class now. Same link or anything changes in the link, I will share the link again. But same link you can join at 3:30. Okay.
Yes, sir.
So what 3:30? Not 3:30, man. 2:30. 2:30. Sorry, 2:30. Sorry, 2:30. Okay then. Bye bye.
Bye, sir. Thank you, sir.